Welcome to the Clipper Shack's Q&A series. We're going to cover different types of edges and how they're formed and why the different types of edges vary from each other. We've got the hollow grind, the true bevel, and a true convex edge. Those are the three types of edges there are, and you'll come across all three of them in shear sharpening. The first one, and one of the oldest, is the hollow grind. It's used when the edge of the shear is put against the outside of a wheel. A hollow grind is formed. It's a dish shape coming out to a very sharp point. Then we move over to a beveled edge, a true beveled edge. This would be the flat surface that we're showing here. So we've got our disc, but it is the flat surface. When a shear is pressed against a flat surface, it creates a bevel, a true bevel. It can also be formed, this is an EasyVex wheel. The outside of the EasyVex does produce a true bevel. The third type of edge we have is a convex. Now, the convex, when we push into the outside of, I really can't see what I'm doing here with my fingers, so I hope it's showing. To form a true convex, you're using the inside of the wheel. And that angle, the higher you go in here, the steeper the angle that is produced, but is still in a convex shape. As you can see by that, it matches the inside of this circle at 45. 45 is a little over an inch up inside the wheel. That varies with the radiuses of the wheel. Now, why do we have all these types of edges? Well, this hollow grind produces a very sharp edge. However, it's not backed by any metal. When you look at that edge, it's very weak. It can be bent and it will dull much quicker than a true bevel. A true bevel, that edge is backed up even more. There's more metal behind it, and the only thing that truly matters on a cutting edge is right on the cutting edge. Back here generally becomes cosmetic. When we move over to a convex edge, it has the most metal behind the edge. It forms of all the edges, it forms the most durable edge at the angle chosen. So therefore, the Japanese went to the convex edge to be able to use a higher angle on the shear and not have it break down quickly and become dull. Now, we've heard a lot about micro bevels. Everybody talks about a micro bevel. At first glance, it looks just like a convex edge until you look at it against the surface. It's a convex here, but it's a bevel on the cutting edge where it counts. After several sharpenings, I'll tuck this under, it becomes just like the other bevel. I had to point this towards me. I'm not quite smart enough to be able to work upside down the whole time. Makes life a little difficult looking at things backwards. But for your angle, there we have that, and there we have that. So your micro bevel just is a small bevel, and after a period of time, it becomes just a regular bevel. It's simple physics. It's not rocket science, even though some people want to make this rocket science. I'd please ask you to subscribe to our channel, and thank you very much for your time.